Hey guys, this is the second video to naming binary ionic compounds. The first video we looked at was actually quite simple. We took a name and converted that name into ions, then used the crisscross method to cross over the number to create a formula. Okay, in this case, what we're going to be doing right now is taking a formula and going to the name. This backwards method than what you just previously saw is a little different. It's actually a little harder. Okay, one thing you need to have out in front of you is a periodic table with a list of the groups and their specific charges. You need to check every single nonmetals charge as we go at a certain point. Okay, and transition metals, remember, they need a Roman numeral in their name. So we're going to work through this. Remember these few points as we work through it. Okay, we're going to start out small first. Okay, so let's take a look at a basic note here. Now, if you look at an ionic compound formula and you have to name it, if both elements are representative elements, the A group elements, then name it as you see it, meaning they only have one charge. So essentially, let's look here at the first compound, MgCl2. Okay, magnesium's in group 2A. It only has one charge. Chlorine is in group 7A. It only has one charge. So in this case, you just name it as you see it. So it's simply magnesium chloride. Okay, so find them on the periodic table in those groups and you can recognize that they're representative elements. Okay, very simple. So it's magnesium chloride. Can't get any simpler than that. Okay, let's look at another example. Sr3N2. Okay, what group is strontium in? And what group is nitrogen in? Take a look on the periodic table. Well, strontium's in group 2A, nitrogen in group 5A. So we just name it as we see it. These are two examples. So we call it strontium nitride. Okay, remember the IDE ending on the nonmetal. Strontium nitride. Okay, so that's that. Now let's look at another example, but we're going to start throwing in transition metals. Okay, when you see a transition metal in a compound, be careful. Okay, so when present in a compound, you must determine which charge it has. Remember, iron's got 2 charges, copper's got 2 charges, manganese got like 5, so you need to know which one it is. Okay, you just can't write the transition metal name down without the Roman numeral, unless it's one that only has the one charge. Okay, so we have to be careful and we have to determine which one it is. Okay, so use the Roman numeral in the name for the metal's charge. Okay, remember the Roman numerals we discussed earlier? Okay, take a look at those. Okay, so let's look at an example. Now, there's a few steps we're going to go through and we're going to discuss those steps with this example 3, COI2. Now, find CO on the periodic table. Where is CO located? It's in the D block. It's cobalt. Okay, and I is iodine. I is found in group 7A. So what you want to do is, in this case, you want to split the elements up. Okay, why do we want to do this? We want to split them up, put the cations on the left, anions on the right. This is so we can help calculate the correct charge for the transition metal. Okay, so a lot of work goes in with the transition metals. Okay, next step is uncrisscross. So what you're going to do is this. Okay, so looking at the formula, you're going to uncrisscross. So this 2 goes to the cobalt, and remember there's technically 1 there. This 1 goes to the iodine. So you uncrisscross. You get those numbers by uncrisscrossing from the formula itself. Okay, step 3 is add the correct sign. So we know metals have the positive charge, nonmetals have the negative charge. Perfect. Okay. Remember, iodine's in group 7A. Step 4, very important step. You need to know all your nonmetals charges. or have a periodic table with them listed on it. So check the anions charge from the group's charge off the periodic table. They should be the same. Okay, so after we uncriss-cross, are they the same? So let's take a look. All right, so it's CO2 2 plus and then I 1 minus. Now, what do we got here? We have a 1 minus. Iodine is found in 7A. Group 7A has a 1 minus charge. So this is the correct charge for this nonmetal. So that means this is the correct charge for cobalt. Okay, so we are going to write in the name cobalt 2 iodine, and this 2 is from that 2 plus. It's very important. Checking the nonmetals charge, make sure it's correct, and also checking the charge for the Roman numeral. Okay, and writing the Roman numeral is very important. Okay, so this here is going to tell us if this one is right, and we're going to look at some different examples and switch it up, and you'll see exactly what I'm talking about. Now, if the 1 minus, if the nonmetals charge is correct, then you're finished. You're done. You don't have to do anything. But if it's not the same, there's another step you have to go through, unfortunately. Okay, so let's look at another example here. Au2O3. Okay, so here, where is gold found? Okay, gold is found in the D block. Okay, so what we got here is what we want to do is we want to separate them. AU, O. Okay, then we want to uncriss-cross. Okay, so the 3 goes to gold, and the 2 goes to oxygen. Assign the correct charges. And next we want to check. We want to check the nonmetals charge. Okay, oxygen is found in group 6A. Group 6A should have a 2 minus charge. And oh, look at that. That means that's correct. Good. So that means this is correct. So we're going to simply call this one gold 3 oxide. Okay, gold 3 oxide. All right, let's look at another example. Ni2S3. Okay, where is Ni? What is Ni? Well, Ni is nickel. It's in a D block. It's a transition metal. So we have to split them up. You have to check every single one. Every compound you do. Okay, then uncriss-cross. So the 3 goes to nickel, the 2 goes to sulfur. Okay, sulfur is right below oxygen, group 6A. Remember, 6A always has a 2 minus charge. Perfect. And that's the correct charge for sulfur. So that means this 3 plus is the correct charge for nickel. So it's nickel 3. Okay, as long as that nonmetal has the correct charge, you're good. Okay, so it's nickel 3 sulfide. Now, what if the nonmetal's charge is not correct? There's a procedure to go through. Very simple. Okay, to solve, multiply the anion's charge by a whole number to make it the correct charge. Now, when are we going to do this? Well, this is after we crisscross and assign charges, and we check the nonmetal's charge. At that point, if they are not the same, this is when we apply this next step. Okay? So essentially, we go from 4 steps to 5 steps. Okay? Then multiply the cation's charge by the whole number. And this would be the 6th step. Okay, so let's take a look here. All right, we're going to look at a new example. Okay, MNO, one of my favorite ones to do. Okay, so let's grab our little pen. Let's move the screen down a little. We're going to need some room. Okay, so first thing is, we notice Mn is a transition metal. We can't just name it. We can't say manganese oxide. Wrong. It needs a Roman numeral. Manganese has a few different ones on there. Okay, so it's Mn. N, and then O. Now, in this case, we uncrisscross, but there's ones there. So you uncrisscross. So this one goes there, and this one goes there. Perfect. So this gets a 1, and this gets a 1. Then we apply the signs. 1 plus, O1 minus. Okay. Now, we check the nonmetals charge here. Okay, remember, oxygen's in group 6A. It should have a 2 minus. Should have. But look at that, it's not. So now we have to multiply this by a 2 to get the correct charge. Okay, that's step 5. Step 6 is multiplying this one here by 2. Okay, so it's actually manganese 2 oxide, believe it or not. Wow. Manganese 2 oxide. Okay, let's look at example 7, WP2. All right, so tungsten is a transition metal. Okay, uncrisscross, the 2 goes to W, the 1 goes to P. So it's a 1, 2, sign the charges. Okay, group 5A is where phosphorus is found. It should have a 3 minus. Okay, so we have to multiply this by 3. 1 minus is not the correct charge. It should be a 3 minus. Perfect. So that means we go to this side and we multiply this by 3. Okay, which makes it 6 plus. All right, 6 plus, so it's tungsten 6 phosphide. Perfect. By checking that nonmetals charge, tungsten 6 phosphide. Okay, and the last one like this is this one here, FES. Okay, FE and S. We uncrisscross. There's a 1 and a 1, so uncrissed 1s. So they both get 1s. Uh-oh, sulfur is in group 6A. Should be a 2 minus, so that means you multiply this by 2 to get 2 minus. Okay, so on this side we're going to multiply by 2 to get 2 plus. So that's a long negative. Okay, 2 negative is now the correct charge, and you have 2 plus for the iron. Okay, it's not supposed to be 1 minus, it's supposed to be 2 minus. So this one here is iron 2 sulfide. Now, remember, there's some exceptions that you need to know, okay, when you're doing this. Okay, for example, silver. Cadmium. Zinc. And scandium. Okay, so if you get those 4 elements, silver, cadmium, zinc, scandium, there's a couple other ones, but these are primarily the 4 most important ones in a compound. You don't need a Roman numeral, even though transition metals. So let's take a look here. So say you got Ag3N, okay? Simple, silver nitride, that's what we call it. We don't say silver 1, we just say silver nitride. Sc2S3, Sc is a transition metal, but we don't use a Roman numeral with it because it only has 1 charge. Okay, scandium sulfide. That's just how we name it. Okay, that's it. So now, take a look here at these problems I want you guys to do. All right. For the first 3, write the formula, and for the last 3, write the name. Practice these right here, okay, and then write the correct answer down. The next slide is going to be answers. Check your answers. Really try to see if you can get it. Okay, so the next slide, pause the video right now.